YouTube channel. In today's video, we're going to learn how to plot 3D graphs on your calculator. This is a useful skill to have, especially if you're a student or professional who deals with three-dimensional data. Plotting 3D graphs on the TI Inspire calculator is a useful and important tool for a variety of reasons. One major advantage is visualization. 3D graphs provide an intuitive way to visualize complex mathematical equations or data in 3 dimensions, allowing you to see the relationships between variables and how they change. By being able to view data in this way, it is easy to identify patterns and gain a better understanding of the information. Another benefit of 3D graphing is the ability to explore equations and data. The calculator allows users to experiment with different values and parameters of equations, providing a more hands-on approach to problem solving. This can help identify solutions to problems that may not be easily seen in 2 dimensions. So, to start off, we're going to click on New, Add Graphs, then we're going to go to Menu, View, and click number 3, which is 3D graphing. So this right here is where we're going to write our equations, and this is the 3D diagram that we're going to see. So let's just take a random equation. Let's start with a simple one, x plus y. So as you can see, the calculator plots what we just wrote. So this is what x plus y will look in a 3D representation. Now, when you enter an equation into the calculator's 3D graphing feature, it uses a mathematical process called parametric plotting to convert the equation into a series of points that can be graphed in 3D space like this. The calculator chooses a range of values for a parameter, usually denoted as t, and uses the equation to calculate x, y, and z coordinates for each value of t. It then plots these coordinates as a series of points in 3D space and connects these points with lines or surface to create the graph of the equation. This process allows the calculator to create a 3D visualization of the equation, which can help you understand its behavior and relationship between variables. So, now let's continue experimenting with what we have. Let's try a little more complex situation. How about x squared? So now you can see the calculator forms this really cool curve that can be used to represent graphs. There are also some cool features that you can use here, such as this. You can use this to move the 3D figure around all 360-degree axis. And then you can also use it to zoom in and zoom out. So to zoom in, you click on the multiply sign, and to zoom out, you click on the division sign. You also get different perspectives. So if you click on X, you get the X perspective, Y for Y, and the same for Z. Pretty good, right? Alright, so now how about we try another equation? Let's try x squared plus y squared. So now we get a parabola. Let's try making something today. How about we try a sphere? Pretty cool, right? Alright. So a parabola is similar to a sphere. Now we can use a knowledge of circles to turn this parabola into a circle. Well, the equation for a circle is x squared plus y squared equals whatever the radius squared is. So let's use our knowledge and start off by square rooting whatever we have, because we want to graph the top part of the circle, and the formula is x squared plus y squared equals to the radius. Therefore, for a sphere, a 3D diagram, it's going to be the same, but with z squared this time. So let's do that. I'm going to select everything, and I'm going to root them. So let's solve the equation for z. So we'll take 4 as our radius, and so the equation will be 4. Now 4 is just an example, you can take any number. Let's take 4 square minus brackets x squared plus y squared. So this is just the equation for the top part of a circle. So if I press enter, we should get the top part of a sphere. There we go. Now something cool that you can do with this is that you can change the color up to your own customization. So you can You can choose from the top and the bottom, so let's go for red at the top and yellow at the bottom. Click OK, and as you can see, it provides what we just wrote: red on top and yellow down. Another cool thing you can do is, if you click on this again, color, custom plot color, and if you click on vary color by steepness, look at that, you get a cool gradient and a shade of blue. Let's just stick with this for now. So now that we've got a top half of the circle, let's try and find the bottom half. Now for the bottom half we have to use the same equation, but we already have the equation of the top half. So all I'm going to do is, I'm going to take x square, and this time rather than writing the whole entire equation, I'm just going to write minus z1, which is basically the top half, brackets x comma y, and if we press enter we get the bottom half as well. Now the reason why we are not getting the whole entire circle is because the function doesn't recognize this circle to have a vertical line in between. So right now it's just going to be like this. Now we can also change the color for the bottom half, so let's do that. Let's try the same, vary color by steepness, and there you have it. We just made our first circle together on the Int'l calculator. Now you can use the same theory to plot other shapes such as squares, rectangles, triangles, and in our next video we're also going to learn how you can extend this theorem to make 3D animations. By following the steps outlined in this tutorial, you should now be able to plot 3D graphs on your Int'l calculator with ease. Remember, practice makes perfect, so don't be afraid to experiment and try different equations to see what kind of 3D shapes you can create. With a little patience and perseverance, you'll be able to master 3D graphing on your Int'l calculator in no time.